Okay, arithmetic series and sequences, day 2. So now today we are going to learn this, what's called sigma notation. And so it is this big E, and the number on the top here, that's 9, is going to be the number of terms. So number of terms. And then the formula that we see, the expression right here, this is the explicit formula. And then the number underneath is just saying the starting A value. So like A of 1. So this is just saying it starts at A of 1. It's not actually the first term though. So we are going to go ahead and just ignore that for now, so that we're only focusing on the main parts. And so it says, what is this? And so again, it's sigma notation and it's saying, what is the sum? So it's asking, what is the sum? Is what the question is asking. So we're going to take this and remember our sum formula we learned yesterday. The sum of n terms is n divided by 2 times the first term and the last term. So we need the number of terms, which is 9. So n equals 9. We need the first term. So we need to figure out what the first term would be given this explicit formula. So we're going to go ahead and plug in A of 1. So we do 2 times 1 plus 6. So 2 times 1 would be 2 plus 6, that would be 8. So our first term would be 8. First term is 8. And then we also need to know the last term. And in this case, if there's 9 terms, we need to know the 9th term. So I'm going to do 2 times 9 plus 6. And that is going to be, oh, why am I doing plus? Sorry, it should be minus. Change that up real quick. Sorry. So that should be minus 6. And then, so that gives us a negative 4 for our first term. And then down here, minus 6. So 18 minus 6, that would be 12. So now we have the n, the last term. We know what the n is, so now we can go ahead and plug in. So S of n, which is 9, equals n terms, so 9 divided by 2 times the first term, negative 4, plus the last term, which we said is 12. And then we simplify. So we would do negative 4 plus 8, or excuse me, negative 4 plus 12, which is 8, times our 9 divided by 2. So if we did that in a calculator, we would get 36. Okay, and the next one, it's saying, how can we write this series here in sigma notation? And then what is the sum? So we have to do 2 parts. We have to write it in this format, and we're going to have to find the sum. So to write sigma notation, we need to find the number of terms. So we don't know how many terms are in the middle here, so we have to figure that out. So 2 plus what would be 9, so that would be plus 7. So we can see that we're adding 7 each time. So if I make a list, I would go 2, 9, 16, add 7 again. We would get 23, and then continue to add 7 until we get to the 79. So we're at 44 right now, and we're going to keep going. So 51, 58, 65. So I'm counting by sevens. and I'm at the 79 now. So I need to count how many there are here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 terms. So I'm going to write up here 12. And then it's going to start at 1. It's always going to be I equals 1 down below for now. And then now I need to know the explicit formula. So I have to find the explicit formula. So we have A sub n, and then our first term, so 2, plus n minus 1 times our common difference, which was 7. And then simplify it. So we have 2 plus 7n minus 7, combined our like terms. So we're at 7n minus 5. So now we're going to take this and write it here. 7n minus 5. So there's sigma notation, and then it says what is the sum. So we also have to do that, but we already have all our information here. I'm going to erase this, sorry. I don't have enough room. So we know that there are 12 terms. And then we know what the first term is because we found it here, 2. And then we know what the last term is because it was given to us also, 79. And then simplify. So this would be 6, this would be 81, multiply that, and we get 486. Go ahead and try the next 2. Okay, so in this one, our n is 13, and then we needed to find our first term and our last term, and then plug it in. So we got 299 there. And then this one, we needed to find the common difference, which was 5, and then I had to list out everything that was in between here to find the number of terms is 8. And then we found our explicit formula here to get this part, and then we found the sum by having the 8, knowing the number of terms, 8 being our first term, 43 being our last term. Okay, so now we're going to look at some story problems, but still looking at series. So we have a display in a store that the top row has 1 can. So I would have a can here. And then the second row has 2 of these, so I would draw 2 of them. And the third row has 3. So 1, 2, 3. Because you can kind of think they're just building the little pyramid idea. So we would have the 3 cans there. And if there's 10 rows, so there's even more. So we can count if you wanted. 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there's 1 can, 2 cans, 3 cans. We can kind of see that it's just adding 1 each time. So we could just say that these are the numbers of cans as well. And then it says, if there are 10 rows of cans, how many total cans are there in the entire pyramid? So I'm going to erase this to get it out of the way. And so we are going to be using our sum formula. Okay, so I'm going to be plugging in the information that I know. So my n is going to be the 10. And then the first row is 1, so that's going to be there. And then the last row we said has 10, so that's going to be there. So I'm going to plug this in. So S and then This is the part that's always there, right? And then we just plug in. So we have n is 10. We said our first term is 1 and our last term is 10. And then we just solve that. So that would be 5 times 11. So 55. So there are 55 cans in the display. Go ahead and try the next one. Okay, so this one had 15 in the first, and 17, then 19, and there's 16 stairs total. And these are the numbers here representing the bricks in each stair. So it goes up by 2 each time. So I found all of them, and the highest one was 45. And so I plugged in, my number of terms was 16. My first term was 15 bricks, and the last one was 45 bricks. And so I found the sum of them, showing that we needed 480 bricks for these stairs. And that is it for 1.4.